In this hands-on session, we are going to create a Kubernetes deployment, which allows us to manage multiple replicas of a pod and perform rolling updates. We will start with the declarative method by writing a YAML file inside VS Code. Then we will use the imperative command to create the same deployment. Finally, we will explore how to debug and troubleshoot a deployment. Let's start by creating a deployment using the declarative method. Below is the YAML file, and I will explain each line step by step. The API version apps/v1 sets the API version used to create the deployment. The kind, deployment specifies the object type. Under metadata, we provide identifying information, including the deployment's unique name, my deployment, and labels for organization. The spec section defines the desired state, including replicas, 3 to maintain 3 pods. The selector identifies which pods belong to this deployment using the label app nginx. The template section defines the pod template that the deployment will create, including metadata labels, container name nginx container, image nginx, latest, and the exposed port 80. This deployment ensures that 3 identical pods are always running and managed by Kubernetes. To create deployment using this YAML file, we use the command kubectl apply-f deployment.yaml. Make sure you opened a terminal in the same folder where you created the YAML file. To check if the deployment is created, you can run the command kubectl get deployments-n default to get all deployments in the default namespace. Now let's create the same deployment using the imperative method. We use this command kubectl create deployment my deployment nginx --image equals nginx latest -- replicas equals 3. This create deployment, named my deployment, and image equals nginx. Latest sets the container image for the pods. Replicas equals 3 specifies the number of pods to maintain. Once the deployment is created, let's see how we can debug and troubleshoot it. kubectl get deployments n default. This command lists all deployments in the default namespace, showing their names, replicas, and current status. kubectl describe deployment my deployment. This command shows detailed information about the deployment. Its name, my deployment, and it's located in the default namespace, is successfully running with 3 replicas, all updated and available. It is labeled with app equals my deployment and uses the selector app equals my deployment to manage pods. The deployment employs a rolling update strategy, allowing up to 25% of pods to be unavailable during updates. The container runs the nginx latest image with no specific port, volumes, node selectors, or tolerations. The replica set has scaled up from 0 to 3 pods, and the deployment is progressing without issues. kubectl get pods my-l app equals my deployment-n default. This command lists all pods managed by the deployment, filtered by the label app equals my deployment. kubectl logs pod name. This command displays logs of a specific pod using its name, useful for troubleshooting container issues like what we did in previous pod hands-on. kubectl rollout status deployment /my deployment. This command checks the rollout status of the deployment, ensuring pods are created and updated successfully. kubectl delete deployment my deployment. This deletes the deployment and all its managed pods, useful for cleanup. In this hands-on session, we created a Kubernetes deployment. We built it with the declarative method using a YAML file, then created the same deployment using the imperative method. Finally, we explored how to debug and troubleshoot a deployment with kubectl commands. Deployments are fundamental for managing multiple replicas of pods and performing rolling updates, which ensures application availability and smooth upgrades.